So this is problem 2-1 of the AP Physics Review book. This problem deals with Newton's second law and also some parts about frictional forces. So you have this 300 kilogram box resting on a platform attached to a forklift, and it's accelerating downward at 1.5 meters per second. So problem A, you determine the upward force exerted by the horizontal platform on the box. So for this problem, you can see it as a free body diagram. You have your box here. There is a downward force on the box caused by gravity. This is equal to mg, and then you have your normal force. And you're solving for the upward force, which would be this normal force here. So, do Newton's second law, F equals ma. The net force is equal to this combined force here, so that would be mg minus normal force equals ma, and then you're solving for n. So just rearrange the equation to get n equals mg minus ma, or m times the quantity of g minus a. And then from there you can plug in values from the initial problem. The mass was 300 kilograms. The force of gravity is 9.81. And then from there you subtract the acceleration, which is 1.5. And then calculate that out, and it comes out to 2,493 newtons. So that's part A. Then move on to part B. It is asking you to determine the frictional force on the box once the forklift begins to move forward with an acceleration of 2 meters per second. So, what's important to realize here is that the only horizontal force on the box is the frictional force. So, you can isolate the horizontal forces. Fh equals ma h in the horizontal direction, using just Newton's second law again. So from here, you can just basically calculate it out. It's equal to the mass times the horizontal acceleration, which is 2 meters per second, and you get 600, and that is your answer. For part C, given that the box does not slip, determine the minimum possible coefficient of friction between the box and the platform. So you need the equation for the coefficient of friction. So you have your coefficient is equal to, you have the force. The friction is equal to the coefficient times the normal force. So then just rearrange the equation. You solve for your coefficient equals force of friction over normal force, that is. And you've already solved for both of these in the previous problems. The frictional force is 600 newtons, as you can see in part B, and the normal force you calculated in part A was 2,493. And the answer to this is approximately 0.24. For part D, it is asking you to determine an equation for the path of the box, y in terms of x, and not of t, which is what we've been working in, assuming that some initial horizontal position is 0, vertical position is 2. So you can see here, this right here would be 0, this position will be 2, sorry. So first, to do this problem, you need to solve both equations in terms of t, which is what we've been working in. For this, you'll use this is one of the kinematic equations of motion. So let's do y first. Y is equal to y naught plus the initial velocity times time plus 1/2 acceleration times time squared. Pretty basic equation. So simplify that down. You have y naught. Your initial velocity was 0 plus 1/2 times the acceleration. It's the box is dropping down, so it's negative acceleration. So negative 1.5 times t squared. And to simplify that even further, you were given y naught in the problem, it's 2. Just remove that, minus 0.75 times t squared. There you have your y in terms of t. So now x in terms of t, x is equal to x naught plus v naught t plus 1/2 times acceleration times time squared equals 0 plus 0t, since both of those initial values were 0, plus 1/2 times 2t squared. And of course this simplifies down to just t squared. So you have x equals t squared. This turns into, sorry, I've lost focus there. X equals t squared becomes t equals the square root of x. So you plug that value into your equation for y that you had here, and you get y equals 2 minus 0.75 square root of x squared, which is equal to 2 minus 0.75x. And that is the answer to part D. Let's move on to part E, which is the last part. In fact, I will do it on the actual book itself. You are going to sketch the graph of the equation. It's a pretty simple linear graph. Y equals 2 minus 0.75x. You'll start with your y-intercept at 2 right here. The slope is 0.75, so for every 1 unit you move down over across, you'll decrease by 0.75. Decrease by another 0.75 at 2, so you'll be at 0.5 here. And decrease by another 0.75 3, so you will be at negative 0.25. And then you would draw a straight line to connect all of those. And there you have it. That's the problem.